Hi everyone. In the given problem statement of longest consecutive sequence, we are given an unsorted array of integer nums. Return the length of the longest consecutive element sequence. You must write an algorithm that runs in big O of n time. So here, right, the one way would be to sort the entire list and find the longest sequence. But if I do that, for the sorting itself, I would have a time complexity of big O of n log n, and our code is going to get time limit exceeded error. So one other way would be, let me draw it up and how this pictorially how it's going to look. So if I do have the element 1, 2, 3, 4, 1, 2, 3, 4, and after a certain point we are going to have this 100 element at, let's say, 100 index, and another element at 200. Now, right, if I search, like, let's say if I got the first element, let's say got the 4 is at the first position, right? If I try to look for an value, let's say 4 minus 1, which is 3, is 3 existing in the current set or dictionary? The answer would be yes. So if 3 is existing, right, the 4 cannot be a starting point. So you have to find an element which does not have, let's say, this 1, right? So n minus 1, which does not have n minus 1 in the set. So if I get this, for example, 1 minus 1, 0. 0 does not exist in this set. So it could be our starting point. So we got 1, then 1 plus 1, which is 2. Okay, is 2 existing in the dictionary, which is correct. Then 2 plus 1, which is 3. 3 existing in the dictionary, which is correct. Then 3 plus 1, 4. 4 existing in the dictionary, which is correct. But 4 plus 1, is 5 existing in the dictionary? No, right? So here, right, from here we can see there are 4 elements that is present. And the 4 would be the longest subsequence that could be present out here. So in this way, right, by using this trick, we can easily find the starting element of our subsequence. Now let us jump to the Python solution. Now let me create a variable called longest, which is going to keep track of the longest subsequence. Longest, we're initializing at 0. Then we are taking the nums and taking a set so that there are no duplicates that is present. Now for each in nums, if each minus 1 not in nums, so we are finding the initial element from where our sequence or consecutive sequence is going to get started. So before that, right, the element won't be there. So you can find that this is could be starting point. And let me take a value called temporary length, which is going to be 0. Now while each plus temporarily length in nums, if that value, right, is existing, then we are going to increase the temporary length value by plus 1 length. Now we are going to do, it would be an if condition, right? So longest is whichever is max, right? Current temporary length is maximum or the previous length was maximum, right? So we are going to take that value, longest and temp length, and at last we're going to return that value, whatever the longest consecutive element sequence that we found. Now let me run the code. Let me run for the public test cases first. I hope there are no spelling errors. So as you could see, the public test case is passed. Let me submit the code. As you could see, it's beating 73.74%, and the time complexity of the entire code would be big of n, because it's a pretty straightforward solution. We're just looping through the entire list once. So our time complexity would also be very, very better off. And I think this I once I got 90% or something, so this is not a very accurate measurement. But from here, right, we can see, right, it satisfies the given condition in the description that our algorithm should run in big of n time. So that's all for this video. See you in the next one.